Good morning, students. I am Parvin from Sangam School. Today we will discuss about the new lesson ray optics and optical instruments. What is ray optics? Today we will discuss about ray optics and optical instruments. The branch of physics which deals with the behavior of light is called optics. So, the branch of physics which deals with the behavior of light is called optics. And here, this is called ray optics. Why it is called ray optics? Because the path of light is light ray. The path of light is light ray. So, we indicate the light ray like this. Like this. And light is travels in vacuum also, and it does not need no medium, and the light is travels in vacuum with a speed of 3 into 10 power 8 meter per second. The speed of light in vacuum c is equal to 3 into 10 power 8 meter per second. And light has different properties. They are reflection, refraction, dispersion, scattering, etc. So, light has different properties. They are reflection, refraction, dispersion, scattering, etc. Now, we will discuss about reflection. Reflection. What is reflection? What is the definition of reflection? Now, we will discuss about reflection. At first, we take here, this is one smooth surface. This is one smooth surface, like mirror. We take mirror also here. So this is one smooth surface. Here the light. This is one light ray, and it is incident at point O. And here we take one normal. This is a normal. And when the light ray is incident at O point, then it bounces backside. Then it bounces backside. That is called reflection. It is bounces backside. That is called reflection. So now we will discuss about law of reflection. Law of reflection. Laws of reflection. So here we take a diagram. This is a smooth surface, and here OA is incident ray, and OB is reflected ray, and ON is normal. So here OA light ray is incident at O point. After that it bounces back as OB, that is a reflected ray. And here the incident ray make an angle with normal is I. And here the a reflected ray making an angle with normal is R. So here I is called angle of incidence. So I is equal to angle of incidence. Angle of incidence. And here R is equal to angle of reflection. Angle of reflection. So I is angle of incidence and R is angle of reflection. And here the first point of laws of reflection is the angle of incidence equal to the angle of reflection. That means here angle I is equal to angle R. So the first point is here the angle of incidence equal to the angle of reflection. That is the first point. And the second point is here the incident ray, reflected ray, normal lies in a same plane. So incident ray, reflected ray, normal lies in a same plane. That is the second point of laws of reflection. So incident ray, comma, reflected ray, and the normal lies in a same plane. So these are the two laws of reflection. First one is angle of incidence equal to the angle of reflection. Second one is incident ray, reflected ray and the normal lies in a same plane. So understand ma? Now we will discuss about the another property, refraction. 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 So here we take two mediums, denser medium and rarer medium. Denser medium, it may be water or glass. Denser medium means it may be water or glass. So here we take water or glass. And this is a rarer medium. It may be air. And here the light ray is incident at O point. At O point. After that, here the light ray is passes from denser medium to rarer medium. But here the light ray is not travel in straight line. in straight line, but it is bending. But it is bending like this. Bending like this. It does not travel in straight line, but it is travel like bending. So bending of light which passes from denser medium to rarer medium is called refraction. So understand ma? Here we take two mediums, denser medium and rarer medium. Denser medium, it may be water or glass. Rarer medium, it may be air. Here this is one light ray and it is incident at O point. After that it does not travel in straight line, but it travel in a straight line, but it does not travel in a straight line, but it is bending like this. Bending like this. So bending of light which passes from denser medium to rarer medium is called refraction. So this is a incident ray and this is a refracted ray. Refracted ray. And this is a incident ray. And here the angle of incidence is I. And here the angle of incidence is R. But here R is greater than I. Angle of refracted ray is R. But here the angle of refraction is greater than angle of incidence. So angle R is greater than angle I. 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 So refraction. So bending of light from which passes from denser medium to rarer medium is called refraction. Look at this diagram. This is about refraction. This is denser medium and this is rarer medium, and this is incident ray and this is refracted ray. And here also the light does not travel in straight line. It is bending like this. It is bending like this. So bending of light which passes from denser medium to rarer medium is called refraction. And here the angle of incidence I, and R is the angle of refraction. And here the angle of refraction is more than the angle of incidence. So R is greater than I. Suppose here the light is travel straight, but here the light ray is bending from it passes from denser medium to rarer medium. So bending of light which passes from denser medium to rarer medium is called refraction. And I is angle of incidence, R is angle of refraction, but here the R is greater than I. This is about refraction. Now we will discuss about critical angle. Critical angle. Here also we take two mediums, denser medium and rarer medium. Denser medium, it may be water or glass, and rarer medium, it may be air. Here also this is one light ray. Here the light ray is incident on interface. After that here this is refracted ray. What do you observe here? Here the refracted ray is coincide with interface. Coincide with interface. Refracted ray is coincide with the interface. So here the angle of refraction is 90 degrees. So here the light is travel from denser medium to rarer medium, but a refracted angle is coincide with the interface. So here the angle of refraction is 90 degrees. So we can define the critical angle like when the light ray is travels from denser medium to rarer medium, the angle of incidence for which the angle of refraction is 90 degrees is called critical angle. So light ray is travel from denser medium to rarer medium, then the angle of incidence for which the angle of refraction is 90 degrees, then it is called critical angle. And here we indicate critical angle C. C is called critical angle. So here I is equal to C, and angle of refraction is here 90 degrees. So do you understand the definition of critical angle? So light ray is travel from denser medium to rarer medium, and the angle of incidence for which the angle of refraction is 90 degrees, then it is called critical angle. Then it is called critical angle. And here critical angle I is equal to C. R is equal to, here the angle of refraction is 90 degrees. So critical angle. Now we will discuss about total internal reflection. Here also we take this is interface, and this is denser medium, and this is rarer medium, and this is light ray, incident light ray. This light ray is incident on interface. After that here the angle, we see the angle here. I is angle of incidence, and C is critical angle. Here I is greater than C. That means angle of incidence is greater than the critical angle. So when the angle of incidence is greater than the critical angle, then the light ray is totally reflected into same medium, that is denser medium. It is called total internal reflection. So here the condition is angle of incidence is greater than the critical angle. So when the angle of incidence is greater than the critical angle, then the light ray is reflected back into same medium. That is called total internal reflection. Understand ma? So when light ray is travels from denser medium to rarer medium, where the angle of incidence is greater than the critical angle, then the light ray is totally reflected back into same medium. That is called total internal reflection. Now we can understand simple way to these are critical angle and total internal reflection. To see the diagram here, this is also interface, and this is denser medium, and this is rarer medium. Here we take 3 rays, first ray, second ray, 3 ray. So 3 rays are there. At first here this is first ray. First ray is travel from denser medium to rarer medium. So this is first ray is, this is incident ray. This is a incident ray. It travel from denser medium to rarer medium. Then here the light ray is bending. So here the light is refracted. So here the refracted, this is the refracted ray. This is the refracted ray. So here the first ray is travel from denser medium to rarer medium. Then it is refracted. after that we take second ray. Here this is a second ray. Blue ray is here second ray, and this is also travel from denser medium to rarer medium. But here the ray is refracted ray is coincide with interface. Coincide with interface. So here the angle of refraction is 90 degrees. So here the angle of incidence for which the angle of refraction is 90 degrees. So this is called critical angle. So second ray, here second ray. So I is equal to C. That means this is a critical angle. So second ray, here this is second ray. After that it travels from denser medium to rarer medium. Then the refracted ray is coincide with interface. Then the refracted angle is R is equal to 90 degrees. So here the angle of incidence equal to critical angle. So after that we take third ray. Here this is third ray, but here the ray is third ray. This is third ray. And here the angle of incidence is greater than the critical angle. So then the light ray is reflected back into same medium. So this is third ray. So it when it here the angle of incidence is greater than the critical angle, so it is totally reflected back into same medium. That is called total internal reflection. So from this figure we can understand the refraction, critical angle and total internal reflection. So first ray says refraction, second ray says critical angle, and third ray says total internal reflection. Understand, ma? Are you clear? Now the conditions for total internal reflection. The first one is the light must travel from denser medium to rarer medium. That is the first condition. So light must travel from denser medium to rarer medium. And second condition is the angle of incidence is greater than the critical angle. The angle of incidence, here I is greater than C. That means angle of incidence is greater than critical angle. So these are the two conditions to understand the total internal reflection. So first point is the light must travel from denser medium to rarer medium. And second one is the angle of incidence is greater than the critical angle. These are the two conditions. Thank you, ma.